Hi everyone, I'm here today to show you how you can use Hall effect sensor feedback for positional control of your linear actuator. Hall effect sensors are sensors that produce an output voltage when they are in the presence of a magnetic field. When used with linear actuators, these sensors are typically positioned inside the gearbox of the linear actuator alongside a magnetic disc. As the linear actuator moves, this magnetic disc rotates, which causes a magnetic field to pass by the Hall effect sensor, which in turn causes the sensor to produce a pulse of voltage. As the actuator continues to move, these pulses can be counted to determine how far the linear actuator has moved. To utilize this output signal for positional control, we'll need to make use of a microcontroller, like an Arduino, to count these pulses as they occur and convert them into a positional value. The first thing you want to do is set up the code for your microcontroller to both control and read the feedback from your linear actuator. For Hall effect sensors, you're going to want to make use of external interrupts. Interrupts trigger a segment of code to be ran every time there's a change in voltage. As I'm using an Arduino Uno in this example, I have the choice between pin 2 and pin 3 as interrupts. This segment of code here attaches pin 2 to be my interrupt pin. You also get to choose when the interrupt is triggered. For my case, I have chosen the rising edge of the voltage change. The last thing you need to do to set up your interrupt is write the function that is ran every time the interrupt is triggered. In my case, I'm using this function called count pulses. This is a straightforward function that just simply adds up all the pulses that are detected. I've also added a little bit of a timer delay to help filter out false triggers and to clean up the noise from my Hall effects sensor. We've written our interrupt service routine. We can then enter the main loop of our code. The first thing that will happen in our main loop is that we home our linear actuator. As Hall effect sensors do not provide an absolute position as feedback, we need to keep track of where our linear actuator is throughout the code. To do this, we need to start from a known position, like fully retracted or fully extended. And this is what our homing function does. In that function, there's a while loop where we drive our linear actuator back to our fully retracted position. We check if we've reached that position by looking to see if our steps variable has changed. This variable changes every time the interrupt is triggered. If it has not changed, we know our interrupt has not been triggered, thus our linear actuator has been moved. Once we have determined that, we simply exit the while loop, set a flag so we don't enter this function again, and then we can move on to the rest of our loop. The rest of our loop is used to control the linear actuator with a motor driver board. To learn how to do this, you can check out our other post on how to control a linear actuator with an Arduino. But I've also added some code to update the position of our linear actuator. This function will add or subtract the number of steps I've counted from my interrupt based on the direction of our linear actuator. Inside the loop, I've also added a check to correct the positional value. While a few false triggers may not significantly impact where your microcontroller thinks your linear actuator is, over time this will become a much bigger deal. So every time I reach one of my known positions, whether it's fully retracted or fully extended, I update my positional value to the correct position to improve the accuracy of my microcontroller. Finally, I simply print the positional value to the serial display. I also convert this positional value into inches using my pulses per inch specification of my linear actuator. Now I'm going to move on to showing you how to set up the hardware and give you a demonstration of the Hall effect sensor. So I've now connected my linear actuator to the Arduino using a motor driver board. Again, if you want to learn how to do this, you can check out our other post on how to control a linear actuator with an Arduino. I've also connected the output of my Hall effect sensor into the interrupt pin on my Arduino and powered the sensor through the Arduino as well. Now when I restart the Arduino, we'll run through that same code we just covered. As you can see, the linear actuator is now being homed, driving it back to a known position. So our Arduino knows where to start tracking the position of our linear actuator. Now that we've reached the fully retracted position, we can now control it in whatever method we please. In this case, I'm just using the switch buttons here to drive it back and forth. So, as you can see, I'm driving it forward, and now on the display, we'll see the output of the position in terms of inches. And that's how you utilize feedback from a Hall effect sensor for positional control. You can see all these products and much more at forgelliauto.com.